All right, so as promised, I'm gonna try and make a YouTube series for you guys to teach you about technology. I'm trying to demystify some of the subjects in the space. I know that learning tech from the outside can be really confusing, and I hope that by providing these videos, I'll be able to give you guys kind of a speed up in understanding and getting past the barrier that exists between the people who aren't in technology and aren't doing it every day and the people who are, right? And so to do this, um, I'm gonna just make a bunch of videos basically in this kind of like stream of thought kind of format. But I'm gonna try and teach you the things that I wish people had told me when I first started. So basically, what we're gonna do today, and I've thought about this a lot, trying to find the right subject to start on because starting is always really hard. But I think that what I need to teach, right, to begin with, is binary. Because without an understanding, at least without a basic understanding of what binary is, it's really hard to talk about the rest of the things I want to talk about. So I'm just gonna start with this and see what happens. So let's try starting with binary. So binary, as you probably know, is a series of zeros and ones that represents numbers, right? Maybe you didn't know it represented numbers, but you know it's zeros and ones. So I'm not really gonna go into that, but if you didn't know it was zeros and ones, it is zeros and ones. Now, I think before we go into trying to understand how binary itself works, I think one important thing to know is that numbers can represent anything, right? Like numbers, if you have numbers, you can represent whatever you want. And this isn't like some kind of crazy mathematical thing. It's just true, right? I'll give you an example. Let's say all you had was numbers, but you wanted to convey information like words. You could literally just say A equals 1, B equals 2, right? In your little language, C equals 3, etc., etc. And then if you sent a message to someone where you said, okay, I'm going to send you 1, then 2, then 3, then 2, then 1, they could easily just look at that, look at the map of letters to numbers that you made, and they would be able to say A, B, C, B, A, right? Obviously, I could have written more numbers down and made hello or something like that, but I think you get the point. Um, if you have numbers, you don't just have numerical information, right? If you have numbers, you can make systems that allow it to represent anything. And the reason that I'm telling you this is because if you take a picture, for example, right, the way that it's represented in a computer, uh, a picture at the end of the day is just pixels. And each pixel has a specific color value. But the thing that makes it look like an image or a photograph is that the pixels are so tiny and there's so many of them. And color can be represented by color can be represented by numbers in the exact same way that we just represented letters as colors, right? As numbers, sorry, letters as numbers. So, for example, what you could do, right? And let's say we've only got black and white. You could say that the spectrum of colors from white to black are represented by the numbers 0 to 100, right? Where 50, right in the middle here, could be some kind of like grayish color. Let's go with this. So we go 50% gray, right? And then you could send a grid of information where you put in numbers where you say 1, 0, and then you 75, let's say 50, 100, 100, 0, something like this, right? These are just numbers, they are not colors, but because we know that the data that we're representing here um, is representing the color white to black from 0 to 100, it means that we can translate what is in here to the correct colors. So we could make this black. We could make that one black like so. Make this one black right here. Then we could take this. We could make that 75. And now I instantly regret putting the 75 in there. But I guess the 75, if I look here, would be around there. Something like this. And so now I have represented a picture as numbers, right? I guess that's supposed to be white over there. Let me just do that. It's white. Good. And then you're reconstructing your picture. And this is exactly what a computer does. Now, the reason that I'm bringing this up and the reason that I'm making such a big deal out of it is because if you understand that numbers can represent any information, then you can understand how binary can represent any information if you understand how binary works. Because binary, at the end of the day, just represents a number. So let's take a look at what that means. All right. So let's take the numbers that we understand right now. We understand numbers like 1027, okay? That's because this is called a base 10 number system. A base 10 number system, and it is designed number system. And it is designed to work with 10 digits, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you want to decode what this, how to read this number, like obviously you know how to read this number because you've grown up with base 10 numbers. But if you want to decode how this number is actually read, what you have to look at is where the digit is and what it represents. And so this represents the number of ones in the number. This represents the number of tens in the number. This represents the number of 100s. And this represents the number of 1000s. So on and so on and so on, off into the future as the digits become more significant. Now, with binary, it works exactly the same way. Binary is a base 2 number system that is designed to work with 2 symbols. And so you can write a number like this, for example. But what's really not obvious to people when they start learning about binary is how do you take that concept from above of, you know, like the first digit is the ones and the second digit is the tens, etc., etc. How does that work in binary? Well, the thing is, and you're going to see that what I'm going to do here is it works exactly the same way in base 10, is you take the base, so it's base 2, and every single time you go up a digit, you're just going to multiply by the number 2 again. So it always starts with ones. This is the number of ones. This is going to be the number of 2 times 1, so 2's. This is going to be the number of 2 times 2's, which is 4's. This is going to be the number of 8's. This is going to be the number of 16's. This is going to be the number of 32's. And this is going to be the number of 64's, because every single time I go up a digit, I look at what the last digit represented and I multiply it by 2. And the reason we do that is because it's base 2, right? So if we want to read this number, we can now really, really easily decode it. So we can say there's 0 1's, but there's 1 2, right? There's 0 4's, there's 0 8's, there's 1 16, there's 0 32's, and there is 1 64. If you add all of those numbers together, what you end up with is, what do you end up with? 70, 80, 80, 82. There we are, 82, right? So this number here means 82 in binary. And just being able to understand that binary isn't this like mystical thing is really really important for all the other stuff I'm going to tell you in the future as I continue to make more videos. So, like I said before, um, we can apply that exact same concept to figuring out what a decimal number is. So, let's take the number 157 that is in base 10. So, in the number system we understand. All you have to do is this. This is the number of ones. This is the number of tens because it's 1 times 10. This is the number of 100s because it's 1 times 10 times 10, which is 100. And so then you go, okay, so that's 7, that's 50, that's 100. Plus 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 equals 157. Now, obviously, that is like completely silly to do because we understand 157 just naturally, but binary works exactly the same way. Now, the reason so I'm just gonna go ahead and assume that you understand that now. So why am I telling you this? What's the point? Like why do we care? Well, the thing is that binary has an interesting property, right? And the interesting property about binary is that you can represent it with pretty much anything as long as you can represent two states. And what I mean by that is binary is made up of zeros and ones, which means in order to send it over to someone in a way that they understand, you only need to be able to represent two distinct things, right? So, for example, let's say you have ducks. Oh, that's a bad duck. But like, let's say you have ducks and you've trained them to open their mouth and to leave their mouth closed. Open their mouth. Open their mouth. See, this can represent binary because you could say that when a duck has its mouth open, it's a 1, and when the duck has its mouth closed, it is a 0, right? And so this can be 0, 1. There we are. Let's take a more realistic example. Let's say you have light bulbs. With light bulbs that are on and light bulbs that are off can represent ones and zeros. Something like this. 1, 1, 0, 0, 1, right? Because all you need to do is define what means 1 and what means 0. Morse code is a good example. I don't know if you know Morse code, but in the movies, people are always saying SOS to one another, save our souls. In Morse code, that's dot, 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 dash, 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 dot, 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 which at the end of the day is a form of binary where the dots could be zeros, the dashes could be ones, and the dots could be zeros, right? And more importantly, computers are able to store and use binary because they use electricity, and electricity can have a low voltage, or a high voltage, right? Which can be used to represent 0 and 1. Also, radio waves, which you see every day in your car, can have a low frequency and a high frequency, which can represent 0 and 1. And those facts alone have basically the fundamentals of all computing. The ability to represent information as binary, and any information that you want. That means, the images, the letters, anything you want. The fact that you can represent that as binary and you can store it in your computer and you can transform it using a CPU is what allows us to do absolutely everything. So I'm going to stop there, but I'm going to move on from this very quickly. I know this was a very basic thing to talk about, but I needed to start somewhere. And now that we understand that binary represents information, I'm very, very quickly going to explain to you how the internet works and go in that general direction. Anyway, so I'll make a video again soon. Have a good one, guys. Bye.